Alright, let's take a look at this problem here. We have two op amps that are cascaded together or put back to back, and we're going to try to determine the voltage transfer ratio, which is our V out over our V in, the source, which is technically our initial input on the first op amp. So we need to find the ratio of the output after the second op amp to the voltage source at the first op amp. Okay, and we're told that R is going to be 10 kilo ohms. Right. So that's just additional information. I'm going to solve this in a general form where it's not really going to matter. The only thing to know is that since R is 10 kilo ohms, the way the system is drawn is all the resistors are actually the same value. So that's makes our life a little bit easier. But the key to solving this cascaded circuit or op amp circuit is to recognize the configuration of the op amps. Okay, so if you look closely at the first stage, which is, let me go ahead and highlight it in green. Let's look at this first stage here. Right here, if we look closely at this, we'll recognize that this is a summer. Okay, and I'll show you how to recognize that in a second. So this is a summer. Okay, and then if we look at the second stage of it, which is the second op amp, okay, we're going to recognize that as going to be a non-inverting amplifier. So it's going to be a non-inverting amplifier. If we look at the second stage here, it's a non-inverting op amp. Okay, so that's the key to solving this problem. So once we recognize this, then it's just a matter of just paying attention to some details and coming up with the equations here. Okay, so before we move forward, let me just remind you as to what a non-inverting amplifier looks like, as well as what the summer looks like. Okay, so let's go ahead and draw this. Let's look at the non-inverting amplifier one first. Okay, so the non-inverting amplifier, if we draw it, if you remember, looks like this. We have an op amp, our inverting, non-inverting. We have our output, V output here. We have our feedback resistance coming in here, so we're going to call this RF. We have some voltage source coming in here, we're going to call V input. It's going to be grounded, and this ground is going to come out here, so we got plus minus, and then over here we have and resistance coming in here, R1, and that's going to go down to the ground, and that's supposed to be connected there. Okay, so this is a non-inverting configuration. Okay, so the key is to figure out how this guy is connected to the other blue there. Okay, recognizing that pattern. Okay, and this one's actually not that hard to see if we just focus on it, and we'll break that down in a second. But the key here is remembering the equation for the non-inverting. So our output is going to be V output equals 1 plus our feedback resistance over R1 times our V input. So that's that relationship we're going to be dealing with here. So we need to know this because that's going to help us in figuring out this ratio. the second part of this, or the first stage of it, if you will, is actually the summer. Okay, and this one's a little harder to see, but let's go ahead and draw it. So remember, the summer looks like this. We have one input, another input. We're going to call this R1, R2, V1, V2. Connect these here. This is going to come in to the op amp inverting in terminal here. Positive is going to go to ground. Our output, V output, going to be out here, plus minus. And then of course we have our feedback resistance, RF. Okay, so this is the configuration for our summer. Okay, and we know the summer equation is V naught, or V output, is equal to minus RF over R1 times V1 plus RF over R2 times V2. Okay, so that's the second equation. So we're going to use both of these to determine that ratio. Okay, so before we move on, let's go ahead and highlight this. So this is going to be our summer stage, or the first part of it. Now, the trick here is with cascading circuits is essentially what's going to happen is the output here coming in here, it's just going to come, because in a cascade, it's just come into this input here. So we need to figure out what the output is here to become the input to the second stage. Okay, so what we need to do is figure out what the summer output is, and that the output of the summer is going to become the input of our non-inverting, this guy, non-inverting amplifier. So that's another point we have to recognize to help us understand how to put this together. Okay, now let's back up and look at the non-inverting amplifier. Okay, let's back up and look at that. For the non-inverting amplifier, we see that the circuit is essentially flipped. So I'm going to go ahead and I'm going to go choose, let me just use I'll just stay with the purple here. So our voltage input, okay, for our non-inverting amplifier, so we have a resistor coming in here, that's grounded. That's the same thing as this R1 coming down here, grounded. Okay, this is going to be our feedback resistance. Thankfully, in this circuit, all the resistances are the same value, but in case they weren't, it's just good to recognize that this would be our feedback value there. Okay, and note that the terminals are, or the positive and negative are flipped here, as opposed to what it would be here. Whoops. Okay. All right. And so this is our feedback. This is technically our R1. And then our input VI is actually going to be the output of our summer over here. So that's technically our VI. Okay, so let's go ahead and write this down just so we can see it. So this is technically, we can think about this as, again, this is the non-inverting amplifier. So this is going to be R1. This is going to be our RF. Okay, if we had, and this would be our V input here, if we're looking at this equation right here. So that would be how we would connect that. Okay, and then of course, using that, we can plug that in there. So let's back up. Let's go now, move forward and work backwards to our summer. Now, if we look at our summer, it's a little harder to see, but essentially what we're seeing is that we have one input. Let me go ahead and we have one input here, and then we have another input coming in from V output that's coming in out here. So this here is going to be one input. This is going to be another input into the negative there. So this would be like our R1, this would be our R2, this is going to be our feedback resistance, okay, and everything here, this is grounded because that's what the summer does there. So let me draw this here. So let me write this first. So this technically would be our, in this case, this would be our R1 for the summer. This would be our R2. I mean, it doesn't really matter. Let me just go ahead, just for sake of convention, let's just say R. Let me just rename them as V. Let's just say this is my R1, this is my R2. It doesn't matter. You can, as long as you're consistent. This is my RF for the summer stage, okay? And of course, this is our V output here for the summer. And then V source is going to be Vs for R1, and this is going to be V naught for R2. So let me go ahead and redraw this so you can better see that. So for the, I'm going to scroll up. For the non-inverting, if we redraw the circuit that is given to us, what we're looking at is our op amp plus minus V naught coming in this way. This is grounded, plus minus. This is our RF. This is our R1. And technically this would be like V1, V2 from the original configuration, but more importantly, this is our VI here, our V input. Okay, so our non-inverting, this is what we're seeing. Again, I drew that for you over there. And then for the summer, if we redraw that there, our op amp looks like this, minus plus, and make note of the signs here. Okay, we have our feedback resistance, it's coming down here. We have R2 as I defined it. We have R1. So this is all actually going up into the negative terminal. This positive is grounded. And then here we have Vs plus minus. This is really V naught coming in here, and this is RF. This is R1. Okay. And then the output here, of course, is going to be V out, but again, naming convention. But essentially, we're going to combine these two. So again, this is our inverter, and this is our summer. That relationship there. So based on that, we can actually further write this out. So I'm going to make a definition here, and I'm going to say that the output of my first stage here, instead of V out where the purple point is there, I'm just going to call that V1. I'm going to call this V1. Okay. So, and I'm going to define the output of the summer as V1 equals, now we said the equation of the summer is just the feedback resistance over R1 times V1, feedback resistance over R2 times V2. Okay, in this case, it's just all our resistances are R, so we're just going to say R over R Vs, that's going to be this guy coming here, Vs, plus R over R, If you really want to, you could have said RF over R1, RF over R2 as it's drawn here. But because, like I said, they're all the same resistor, in this case our voltage is going to be V output. Okay, so that's what V1 is going to be. The R's essentially cancel out, and then we can just say V1 equals minus Vs minus V output. So let's make a note of this guy. So this is what's coming out at the purple node after stage 1, and that's going to be inputted into stage 2, which is our non-inverting amplifier. Okay, so stage 2 is a non-inverting amplifier, so we're going to use this equation here. Okay, so V output, and I'll go ahead and use blue. Let's just do that. Let's say green. V output of the second one, V output equals, the equation is 1 plus RF over R1. Again, they're the same resistances, so it's just going to be R over R, all times, in this case, V1. Okay, so if you come back up here, V1 is really, V1 is this guy. So now we just need to substitute those into there. Alright, and we said V1 is minus Vs minus V0 or V0, so we just substitute that in here. So we get 2 V1, which equals 2 times minus Vs minus V0, or 3 V0 equals minus 2 Vs. And if we take the ratio of those two, we get V0 over Vs is equal to minus 0.6667. And that's how we solve for this circuit here. Now I went through a lot of stuff here, but go back and double check and make sure that makes sense. If you'd like, you can plug in the 10 kilo ohms, and of course that's all going to cancel, but you can go back and plug this in. But essentially these are the two equations to come up with your ratio. But like I said in the beginning, the key is recognizing the circuit configuration of this entire circuit and recognizing that one stage of it is a summer, the second stage is a non-inverting amplifier, going back to your basics of non-inverting amplifier, the equation, and then the summer, the equation, and knowing when you cascade circuits, op amps, the output of the one is essentially just going to be the input of the other, and so on and so forth. But that's how you solve this problem, and your ratio will be V out over Vs, which is minus 0.6667, and that's all for this problem.